So good morning, everyone. So my name is Jake Schultz. I am with the Boeing company, and we have a topic of flying cars and urban air mobility for the next hour and a half. We have Gwen Leiter from GoFly, CEO of GoFly. We have Felipe Varon from Varon Vehicles. We have Stephen Tibbetts from Ziva Aero. And we have Sanjay Dahl from Detroit Flying Cars. Moderating the panel today will be Mark Moore from Uber Elevate. So now I will get off the stage and let them talk about flying cars and urban air mobility.
To me, I'm thrilled to be here, even though I'm with one of the bigger companies. What you're seeing here is a whole bunch of the small companies, the disruptive companies that can come up from below and create these really neat new opportunities. And I'm very convinced myself that we're in a new age of Wright brother-like flight, where there's all sorts of new opportunities, and that some of these small companies are going to turn into future giant aerospace companies because they have an agility, an ability to execute, and an ability to attract talent that large companies really can't do as effectively. So we're in a very exciting time of disruption in aerospace, especially relating to the urban air mobility market.
Hello everybody, my name is Felipe Varon. I am the founder and CEO of Varon Vehicles. Let's see, it's been a long time since I started working in this idea of creating a new way to fly with, tinkering with motors and electronics, probably some 20 years ago. We've envisioned a transportation system based on flying cars that are friendly enough to penetrate the urban environments. And by friendly, we not only mean the form factor of the cars and of course, the operation of it, but also the way that they can cope with society in many ways. The way we can create jobs, generate employment, and in essence, generate acceptability for our systems. So we've devised a transportation system revolving around a new set of values that we've come up with, trying to think outside the box, outside the aeronautics industry box, and outside the automotive industry box. We think that urban air mobility is going to be a new box, a new industry that requires a new set of paradigms, a new set of values. And we've put our customer base in the center of those values. So we think about things, for example, as the fear of flight. We're having an interesting discussion this morning about the fear of flight and what that means in reality. We have had some sense of how we can approach breaking that fear barrier. So we've designed, and we are designing and working to implement a test urban air mobility transportation system, which of course not only involves the flying cars, our flying cars, but the vertiports, the airspace integration, the traffic management system within those airspace volumes, and so on. So our company, it's a startup, and we are developing that transportation system. We're working to implement a test version of it. And our vision is that this could serve the masses in many ways, not only transporting passengers, but there's all other sorts of business models, such as courier transportation and others as well.
Cool, thanks. So what we are talking about here is something that even Orville Wright wrote about 100 years ago. And that is this idea that aviation can have a daily impact in our lives. So we're talking about this ability to have on-demand aviation in and around cities to enable you to be more productive and have a new choice in how you get around, how you move around. So I want to ask, this has been long dreamed of, right? I mean, going back to Hiller in the 1950s, he was building personal helicopters and really pushing this dream of a helicopter in every garage. So he didn't quite have the technology to pull that off then, but what is it I mean, is it that gridlock has gotten so bad, or that the technologies are finally here, or that there's enough Silicon Valley money to enable wild dreams? What is it that's enabling you to stick your neck out and try to make this happen? I've been working on vertical takeoff and landing aircraft my entire career, 32 years at NASA. That's all I did. And I think you hit the nail on the head, is that to do vertical takeoff and landing previously, you had to embrace such a level of mechanical complexity that it was just onerous at every level, from high maintenance to high acquisition costs to poor payload fraction because there are so many gearboxes and transmissions going everywhere. All of a sudden, we're at this stage where we can take mechanical complexity and turn it into software complexity, and have these digital systems that are driving to essentially solid-state machines. So it really is an exciting set of enablers. What do you see as your market opportunities, and what do you see as products that our audience would care about?
So let's see, markets. We've done a tremendous effort to try and identify that potential market. Of course, I agree with you guys. This is a new industry, and it's like a new era. Urban air mobility is allowing us to dream, or to sort of like bring those dreams, those childhood dreams again, and see them as realizable. So all sorts of applications come to mind, and we have continuous talks about ambulances, where you have a driver, a medic, two stretchers to be able to reach places that couldn't be reached before, because we're now using cars that can have way smaller footprints and access places in cities that other air vehicles are not able to, all the way to courier and deliveries and fulfillments, and of course the logical application, which is transportation of passengers. And I do have to add, I think you mentioned it now, that one thing is the enabling technologies, and we do say that a lot of stars have aligned so that urban air mobility can happen. I've been working on this for over 20 years or something, a long time. But our company was just founded probably 3 years ago, because these stars starting aligning themselves, and adding to that enabling set of technologies is the problem, the mobility problem. So if you look at data on the city traffic and the pollution problem, and the congestion situation and so on, it is getting worse. It is definitely getting worse, and we see that as an opportunity, definitely a huge opportunity, and many countries have growing economies, growing GDPs, where people who are being affected and their lifestyles are being affected by that problem would be willing to pay the added cost of a new way, and a better way, and faster way of transportation. So in that hard effort to identify the markets, we've come to the conclusion that wanting to crawl, I think you use that same analogy, because I've used that all for many years. You first have to crawl, and then you learn how to walk, and eventually you learn how to run. So trying to bring those dreams and that science fiction, that we all have from our childhoods, to reality, what can be done and what should be done first. Well, crawling is what we have to do first, and for us, crawling means a very confined, very controlled environment, a very controlled transportation system, and we think that transporting people, passengers, can be done in the short term, and it is the best potential market. Now, will it be for the masses or not? Will it be for VIPs or not? It's a matter of cost, absolutely a matter of cost, and who's going to be able to pay for that additional cost at the beginning of this new industry? Well, that's a question we're going to need to answer eventually. But of course, strategies and of course time will allow that to those prices to drop, and the target that we have is that we must be able to serve the masses eventually.
I mean, can you tell us about the challenges side of what's going on?
Because we're not just only working on the flying cars, but we're working on the entire transportation system. We have a different set and a broad set of challenges, and of course, the cars themselves are a challenge. We are trying to keep it on on the simple side, trying to build cars that are, that allow us to have a low manufacturing cost and a low supply chain cost eventually, operationally and maintenance and so on. That's our focus. So I think that to add to Jorg's challenges, which I agree with fully, I think there's paradigms that are well established. I mean, I think you, Mark, or probably when you said, I mean, these are new times, and these times probably haven't happened, like you've said, Sanjay, maybe in an entire century. I mean, it's been a long time since the current paradigms have been solidified, and I'm talking about the aeronautics paradigms. We, for example, are trying to convey the idea that we don't want pilots in our flying cars. We need drivers, and that's a huge paradigm to break. We want the operators to be on board the cars because we're very convinced that we need those on board the cars in order to break the fear barrier, the fear of our customers, the fear to fly. So we want them to board a car where there's a driver on board with our company's logo in the T-shirt, and that they see, okay, this guy's been driving the car for the entire day. He knows what he's doing. So that's one of the ways that we intend to break the fear barrier. So that's a huge paradigm. We are finding good grounds. Actually, if you go into our website at varonvehicles.com, you'll see yesterday we just released a press note where we announced that we've just been assigned an airspace to do exercises for traffic management, flying car traffic management. This has been assigned by a classified country's aeronautics authority where we're working to implement our test urban air mobility system. And that at least tells us that we're going in the right direction. But breaking these paradigms, it's probably the hardest thing. Yeah, their flying cars are hard. I mean, there's challenges there. But we think that this is not rocket science. We feel that our flying cars are not rocket science. They are simple enough to be achievable even with commercial off-the-shelf subsystems. The biggest challenges are elsewhere in the established paradigms, I think, yeah.
While the vehicles are taking advantage of these simpler components like electric motors, you do get into, I mean, you mentioned getting away from pilots. So we're getting into these digital fly-by-wire systems that are very reliant on software. So I want to ask, and so you get into this complexity of software systems and the regulatory authorities essentially mandating FDLC or higher in order to have assurance that these systems are safe because they're flight critical systems. So how reliant are you each on autonomy? What do you see your path towards developing the required software? And are you able to have a strategy for autonomy where it's crawl, walk, run, and you're not having to jump to $100 million software certification, even for the initial products?
I just wanted to say that I'm fully in agreement with that. I mean, autonomy is a broad term, a very broad term. When we started this like 3 years ago, the company, and we realized, okay, this is what we want to do, we said we want to do this ASAP. We need to do this ASAP, as simple as possible. As simple. Because we cannot think about autonomous flying cars, bringing all the science fiction into what we can do today. That's probably unrealizable. We said, okay, we realized we need to do this in the simplest way possible, and having an operator on board was the way that we chose to go. Now, the fact that there's a flight computer on board does not mean that the flight is autonomous. So there's certain control that the flight computer takes the burden off that is taken away from the operator. But that doesn't mean that the car does, things on its own. Now, again, that's a broad term, autonomy. If we were talking, in our case, if we were talking about a winged aircraft or flying car, the story would be different. That's why we came up in our iterations with a wingless drone-type vehicle. The technology is already there. I mean, flight computers by any number of subsystems manufacturers can control a drone-type vehicle extremely effectively and extremely safely. I mean, drones are out there. And only leaving high-level commands for the operator. And for that reason is that we call them a driver. And that's the reason why we were able to design and build and operate, and we do all the time, these prototypes with our human machine interface, which is just like that you would find in a regular street car. Steering wheel and a small number of buttons for high-level commands. And that's why we can talk about a driver. And we have demonstrated that concept extensively. And again, that's why we're getting these positive responses from aeronautics authorities. So again, autonomy is a very interesting point. I think that we will eventually get there. I'm a huge believer in technology. Otherwise, I wouldn't be here in the first place, right? But you know, steps have to be taken, and we don't know how long it'll be. If it'll be a year or a decade or how many decades till we achieve some level of autonomy. And then the question is, what is autonomy? I mean, how autonomous is a system? That's a whole different universe there.
One of the really unique characteristics of these vehicles is, and how they're different from the prior generation of aircraft and helicopters, is that they embrace design for redundancy. They're developing architectures where you do have these more compact components, lower cost components, but also lower reliability components. How central is this design for redundancy as part of your logic? That is, you know, if we're talking about flight controllers, instead of having, you know, a Garmin system that's pretty darn expensive, there's many of these open source projects that are developing flight controllers that are drastically cheaper. Can you put them together as a triplex or quad system and even have dissimilarity between different flight controllers, or from the powertrain and control perspective? How central is this enabling concept of designing for redundancy into the vehicles that you're developing? Is it a key enabler? Is it a key architectural decision?
Well, that's a very interesting point for us. I mean, it's very central to our exercise and our architecture. Simplicity for us is extremely important. You know, airplanes are complex machines, right? Aircraft are complex. Helicopters are very complex machines. The more complexity you have, the more subsystems you have, the more probability of failure you have, basically. So for us, designing a flying car that was radically simpler was a central part of our exercise. And we've come up with a vehicle that is basically composed of three things. It's a chassis, it's fixed motors, there's no mechanical parts, no moving parts, hydraulics, no mechanics, no pneumatic systems, because we don't need that, right? I mean, these new technologies enable that. So redundancy by design or by nature, it's there. But as far as the security, or you know, the robustness of those subsystems, well, that's it's an opportunity. When you have simplicity, it's an opportunity to pay more attention and to make more robust subsystems and still maintain maybe even less overall cost. We're not looking at any sort of low-level flight computer or anything similar. We're looking at subsystems providers that can actually provide very robust and very reliable flight computers. Because of course safety, it's paramount. It's the central part of any of our systems. So I think it's not hard to achieve. Even though these are very robust, they're commercially available. With little engineering and little design or non-recurring engineering, this is easily achievable.
Within the three major groups of components in all-electric aircraft, batteries, electronics, and the rotating machinery, which do you think is the barrier to getting things smaller and extending the range?
Maybe I can add to that. That definitely in our exercises, in our models, we've seen that batteries are definitely that gridlock there, that bottleneck on eVTOL. There's many problems with batteries. Of course, the battery itself is one problem. Then we found, and again, this depends on the type of vehicle we're talking about. It may not apply to other vehicles because they're different. But in our case, in our type of flying car, we found that it would just not be viable from the source of the energy point of view either. it would require so much electricity that maybe even the energetic matrix of a country can be unbalanced because of a transportation system implemented in a country. So there's two problems, the batteries themselves, and then where do you get the electricity to charge those batteries in the first place as well. Of course, safety is number one, and not only the actual safety, but the perception of safety. That's extremely important. Then you have, of course, noise is a very critical issue in urban air mobility, but for us, there's another factor for society acceptance, which is the opportunity to create employment. So we are talking about a network with maybe hundreds, if not thousands, of flying cars, and that for us, multiplied by 3 is the opportunity of employment for drivers, and that is another way to generate acceptance by society.
What in the world are we going to call these things? Because thank goodness we don't say, I'm going to go get in a horseless carriage now.
Yes.
And we came up with the word car.
Well, for me personally, at least flying car is better than air taxi. That's my opinion. My opinion. So we are calling our cars flying cars for now because seamlessness is important, and we're driving them as cars. And we think that is important for adopters, for early adopters, our first drivers, and so on. So it would be great to have a better name, a new name, a more futuristic name sometime in the near future. Yeah.